As with most things concerning marksmanship, there's a fair amount of confusion concerning zero. The question was raised about this old zero target. What was the purpose of those X's? As it turns out, those X's represent the intended point of impact, even though the sights are being held 6 o'clock at the base of this rectangle. The bottom X is the point of impact for the M16A1, and the top X is for the M14. It was proposed by some that this was due to differences of the cartridges, as in 7.62 NATO versus 5.56 NATO. Turns out that is completely wrong. The real reason for the differences in trajectory, and thus the difference in initial intersection, has to do with the weapon design, specifically the height above the line of bore. This is the M14. Take a look at the front sight. It turns out that the line of sight through the sights is about 1 inch above the line of bore. Contrast that to this prototype by Eugene Stoner, which led to the development of the AR-10 and then, of course, the AR-15, which would become the M16 series. Look at the difference in height of that front sight, because one of Stoner's design ideas was to keep the line through the bore and thus into the stock all straight. Well, you have to have the sight considerably higher in order for a shooter to be able to see it. That design influence, of course, carried over into the M16 series, such as this M16A1 is pictured. Once again, because the line of the bore goes straight into the stock, the sight has to be noticeably higher in order for the shooter to be able to sight through it. To illustrate that this is in fact due to the design of the firearm itself, specifically the height of the sight above the line of bore, we're going to compare two rifles firing the exact same cartridge. The first is going to show the trajectory of a rifle shooting 5.56 NATO. This would be basically like M855 ball, with a rifle that has the line of sight 1 inch above the line of bore, rather like the M14. The second rifle is chambered in the exact same cartridge. We're shooting the same M855 ball. You'll notice that every number here is identical except the sight height, which is 2.5 inches. In other words, the same line of sight above the bore as you would get with an M16. And this shows the trajectories compared. Once again, both rifles are shooting the exact same cartridge. The only difference is the line of sight above the bore. The blue line is the rifle with a 1 inch difference, just like the M14. Notice that it is intersecting before it gets to 25 meters. That means by the time it's at 25 meters, the trajectory is above the line of sight. In contrast, the green line, that's your 2.5 inch, which would be like the M16. That's not intersecting until we get almost to 50 yards, which is going to be close to 42 meters, which is going to be what that initial intersection is for a 250 zero. Notice that the zero distances are exactly the same. This demonstrates how much of a difference in trajectory you get with a difference in line of sight above the bore, even when shooting the exact same cartridge. The old 4 fundamentals model and this target is largely to blame as to why soldiers are so confused about this. The Army spent a considerable amount of time trying to ensure that soldiers don't have to understand these things, and it has essentially backfired. The previous target required at least some basic knowledge as to why. There's 2 X's, therefore 2 different points of impact. Well, gee, drill sergeant, why is that? And that would require you having some knowledge of the difference between the two systems. It just so happens with the old M16A1, if you use the L or long range aperture on your rear sight and you get a point of aim, point of impact exactly at 25 meters, that will yield a good long range zero for your rifle. Once zeroed at 25 meters with the L or long range sight, merely flipping the rear sight back produces the then doctrine specific 250 meter zero. In other words, the regular aperture, not the L aperture, but the regular one, if you do this procedure correct, you walk away with a 250 meter zero. That's all well and great as long as everyone only uses an M16A1 and iron sights and nothing else. With new technology provides new options. Unfortunately, they're only helpful if you know how to implement it, because the Army had spent decades teaching people that they didn't need to understand trajectory and therefore you could use some simplified zero procedure. Well, that actually started to bite them when all of these options started to be presented. The stopgap attempted fix was this, the Small Arms Integration book. It basically was, instead of teaching trajectory and concepts like mils and minutes of angle to the general soldier, we're just going to create an index of charts that shows all of the different potential offsets necessary to conduct your zero at 25 meters. So the simple solution was, instead of teaching you what trajectory is, we need a 448-page book of indexes and charts in order for you to figure out how to do this. From the Small Arms Integration book, this shows an example of the difference in point of impact necessary when using the PAC-4 laser, depending on how you happen to mount it on an M16 or M4 series. The bracket you use and where you mount the thing is going to have a very different effect on what the trajectory is, which is going to change where your point of impact needs to be at 25 meters. Now, all of these variables and differences are well within the command of someone who's a generally knowledgeable shooter. The problem is most soldiers aren't. If you don't understand why there needs to be a difference because the Department of Army spent decades preventing you from having to learn it, well, you're going to have confusion when all of a sudden now you need to be up to speed on the differences and why. Thanks for watching. Please like, share, and subscribe. And share this with some soldiers or other shooters that might be helped with this information.